Okay, today we're going to be talking about graphing polynomial functions, and we're going to first talk about graphing them by hand. So we're going to start with an x to the third function. And what you really want to keep in mind here, we're going to start with just the very simple parent function. And what you want to keep in mind is kind of the x and y values of your parent function. So if I plugged in -2 in here, -2 to the third, I'd get -8. If I plugged in -1, I'd get -1, and so forth. And we can plot this very easily, right? 0, 0, -1, -1, -2, -8, 1, 1, and 2, 8. And the function would look like this. And we note that the exponent here is 3, which is an odd number, and the ends of my graph are kind of going in opposite directions, which is what you would expect from your table of values here. All right, our functions are going to do shifting just exactly like they did when we had our quadratic functions. So here we have a 4. So I'll do this one here in purple. So this one's here is just going to be a vertical shift of 4. And the easiest way to graph these is to first graph your shift of 4. So 1, 2, 3, 4. So I'm going to start here at 0, 4. From this point, I am now going to ignore that. And I'm basically going to graph my parent function y equals x to the third. But I'm going to graph it from this vertical shifted point. So I'm going to think of this now as my new 0, 0, or my new origin. From here, I'll go over 1, up 1. I'll go over -1, down -1. I can go over 2, up 8, but I'm off my graph. So from this origin, or this new shifted origin, I can go over 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you can see I can just kind of take my graph and give it the turn that it needs. If I were to graph the next function, which here would be a shift of -2, I would do a very similar thing, except I would take my origin, shift it down 2, and now I'm going to ignore that shift, and I'm just going to graph y equals x to the third from my shifted point. I'll go over 1, up 1, over 2, up 8. I'll go over 1, down 1, and over 2, down 8, and again, I'll be off my graph. And I'll just kind of connect my dots and give it a nice little curve like that. Sorry, hold that thought. All right, so this now is going to be a horizontal shift. So now I'm going to be shifting over +2. Remember, in horizontal shift, it's always the opposite value. So I'm going to be shifting over 2. And once again, it's a third degree function. So I'm a power of 3. So I'm going to go over 1, up 1, over 2, up 8. Let's say 1, 2, 3, 4, 5, 6, 7, 8. And I'll go over 1, down 1, and over 2, down 8. Draw my graph like that. If I had a shift over here of x plus 4, that would actually give me a shift over -4. And then I could graph from that point. So this here would be your horizontal shifts. And again, if you did both shifts, I'm only going to do this one here in red. I think you can figure it out from there. My shift is going to be over 2, down 3. From this point, it's a cubic function, so I'm going to go over 1, up 1, over 2, up 8, and over 1, down 1. And again, I'll be off my graph, and I could just do my curve like that. When you have a negative sign, you're really going to be thinking of it as the same way. So if I made a table of values here for x, y, I could still plug in my same x's that I did before, -2, -1, 0, 1, 2. But now if I plug in a -2, I'm going to get out a -8. but then there's this negative sign here, so it's negative -8. So now this would give me a positive 8. This will give me a positive 1. This will still give me a 0. This now will give me a negative 1, and this now will give me a negative 8. So this is going to create a flip, which you'll see in just a second. So I'm going to go 0, 0. I will go negative 1, positive 1. I will go positive 1, negative 1, over 2, up 8, and over 2, down 8. So you can see now that this is what the equation would look like if it had a negative sign. The same thing here now, this would just create the same graph, but it would move it over to the right 4. So it's as if I could just pick this graph up and place it over 4. And then this one here would be over 2 and up 4. So to the left 2 and up 4. When you have a 2 in front, again, if you remember from our quadratics, I just kind of called that a y multiplier. So if you think about your standard xy table, if it's a cubic function, again, I'm going to have -2, -1, 0, 1, 2. Normally, I'd have -8, -1, 0, 1, 8. But now I have this y multiplier. So I'm going to take all my y's and multiply them by 2. So this would be -16, -2, still 0, 2, and 16. So it's just going to kind of stretch my function a little bit. So I'm still here at 0, 0. I'm going to go -1 down 2. I'm going to go -2. Now I have to go down 16, so I'll be down there somewhere. I'm going to go over 1, up 2, and I'm going to go over 2, up 16. So it's just going to kind of take my function and just kind of stretch it out a little bit. Right? And then once again, this will give me a horizontal shift 3, -3, and then down 2. So it's as if I could just take this origin and plunk it right down there. Your fourth degree functions are really going to be very similar, not really any different, except your parent function has different values. You really don't even have to consider these values because they're really going to be pretty much off your graph. And you know kind of what your what your graph will look like. It'll be what we would call parabola-ish. It's going to look like a parabola as an x to the fourth, but you're going to see as we add some more terms to a fourth degree equation, it's going to have some kind of ups and downs in the middle of the curve that's going to not make it look like a parabola. So I'll have 0, 0. I'll have -1, 1. I'll have 1, +1. And it's going to look very much like a parabola. But you'll see when we start graphing them on the calculator, it could very often have some kind of loops in here that will be different. Shifting and flipping is the same as with the cubic function. So if you have x minus 3 to the fourth, that would be a horizontal shift to the right. And if you said +2, then that would be a vertical shift up. If you had some number in here, some a value, then that would just be your y multiplier. A fifth degree function is really going to be exactly like your third degree function, except once again, it's really going to be difficult to graph those numbers by hand because they're going to just get really big and be off your graph. So again, graphing by hand, a fifth degree function is going to look very similar to a third degree when you're just graphing on a small graph like this. And you'll notice that there are certain general shapes of the function. So if a is bigger than 0, or if it's some positive number, and if your exponent here is odd, you know your graph is going to sort of look generally like this. Again, it might have some different loop-de-loos in the middle depending on how high that exponent is, but if it's odd, the ends are going to go like this. If it's negative, it's greater than 0. It was positive, but it's even. Now your graph will have a shape that's going to be sort of like this. parabola-ish. If A is less